Let's explore an example of static NAT. And then we're going to build upon this configuration by looking at dynamic NAT and port address translation. Where's the inside of our network? Where's the outside of our network? Let's identify those first. The inside of our network is this portion right here. The outside of our network is this portion right here. And in this case, we're looking at private addresses and public addresses. So the private IP address space is the 172.16.1.0 network as an example, and our public address space is the internet. But how did we get this public IP address that we see right here? The 209.165.201.1. Well, our internet service provider assigned it to us. They might have assigned it statically to us, or they might have assigned it through DHCP. So let's double check up top at the configuration to see how it was assigned. In this case, we assigned it statically. So we went to the interface, typed in IP address, 209.165.201.1, and gave it a subnet mask. Whoa, well, look at that subnet mask for a second. It's 255.255.255.240. That's interesting. That's interesting. Let's think about how we're connected up to our ISP right now. There we are. There's the ISP's router. And we have this direct connection between our router and the ISP's router. How many addresses, folks, do we need in this case? We have this point-to-point connection between our router and the ISP's router. Yeah, we really only need two, don't we? We need an IP address for our outside interface, and then they need an IP address. Let's say it's .2 on their interface in the same subnet. However, in this case, we need some extra public IP addresses, so that way there we can statically assign public addresses to the devices inside of our organization and have that translation process occur on the router. So in this case, we don't just have one IP address for our network. We have a group of IP addresses that have been provided to us. So what is this group? How many IP addresses do you have? Well, we really have to go back to ICND1 knowledge in order to answer this. And I like to use the block size method. What is the block size method? You take 256 and you subtract from that the value of the most significant octet in your subnet mask, and that gives you a grand total of 16 in this particular example. So what does this mean to us, this 16? Well, the 16 is telling us how many addresses are available within the block of addresses. There's a total of 16. And how do we determine that? Well, since there's a total of 16, if we think it's 209.165.201.0 is the starting of our address block here, then the ending is going to be 209.165.201.15. 16 total addresses. 16 total addresses. We're using .1 on Ethernet 0/1. The ISP is using .2 on their router. We can't use .0 because that's the subnet ID. We can't use .15 because that's the broadcast address, leaving us with how many addresses? 16 minus 4. That's 12. So we have 12 addresses left over that we can use for static NAT, meaning only 12 users can access the internet at any given time. We go to our outside interface, and we use the command IPNAT outside. This tells the router that that is the outside interface for NAT. We go to the inside interface, and we type in IPNAT inside, telling NAT that this is the inside interface where the private IP addresses are that are going to be translated to the public IP addresses So they can go out that outside interface and go to the internet. Here's our command that ties it all together. It's what configures that static translation. IPNAT inside source static. IPNAT inside source static. So what we're saying with this command is that we are going to be translating those inside source addresses, so in this case the private IP addresses, to public IP addresses. And we're going to do it using a static NAT translation. And the static NAT translation is this private IP address is being translated to this particular public IP address in our example. Is this a valid public IP address? What do I mean by valid public IP address? Well, if the source address that this PC is using, 172.16.1.10, is being translated to 209.165.201.5 as it's going through this router and then being sent to the internet. When I say, is it valid, what I mean is, can the web server, as an example, that we are contacting reach this IP address in return? Because the return traffic is going to come back to this public IP address. Well, does this public IP address fall within this range? Yeah, it does. So as long as the ISP is advertising the 209.165.201.0/28 network into the internet, so in a border gateway protocol, then the web server will know how to get back to that IP address. So it'll send it to what? It'll send it to its default gateway, that then the routers on the internet will know how to route the packets back to my network, so I can get the return traffic. So it's really important that the addresses you're using are reachable from those destination devices on the internet that you are communicating with. Because if they're not reachable, if the ISP is not advertising them, or you're not advertising them yourself using Border Gateway Protocol, then it's not going to work. Packets will leave, but packets will never come back. So what's this going to look like after in our NAT table? Well, inside of our network address translation table, we're going to have that inside global address that's listed first, and that's the public IP address. So it's going to be 209.165.201.5. That's the inside global address, so the address that the private address is being translated to. And then we have our inside local address, which in this case is 172.16.1.10. And then after that, you have your outside local and outside global addresses. And in this case, we're going to pretend it's the exact same. And it just happens to be the public IP address of www.cisco.com as an example.